Hello everyone. Today's video we need to show that the Poisson distribution is derived from binomial distribution. In our solution, the binomial distribution has the formula n x into bracket p power x into bracket 1 minus p n minus x. Poisson distribution is lambda x exponential of negative lambda over x factorial. So we need to show that Poisson distribution, this one, is derived from this one. So we need to show that this one tends to lambda x exponential of negative lambda all of x factorial. So we know that np is equal to lambda. Np is equal to lambda. This implies that p is equal to lambda all over n. Lambda all over n. So we need to replace this lambda over n in our binomial distribution formula. So it will be, now replace p with lambda for n in binomial formula. So it will be nx into bracket lambda all over n x 1 minus lambda over n minus x So since n combination x is equal to n factorial over x factorial n minus x factorial. Now replace this one to replace so it will be n factorial of x factorial n minus x factorial, and then lambda over n x 1 minus lambda n minus x. This implies that n factorial for x factorial into bracket n minus x factorial x lambda x all over n x 1 minus lambda over n minus x. So therefore this implies that lambda x factorial n factorial n x into bracket n minus x factorial 1 minus lambda x 1 minus lambda x So n factorial here, our n factorial here, when you want to find the value of n factorial is equal to n into bracket n minus 1 into bracket n minus 2 all the way to n minus x plus 1 into bracket n minus x. So replace here. You need to replace here with this one. So it will be x all over x factorial n into n minus 1 n minus 2 all the way to n minus x plus 1 all over n 1 minus lambda for n over n minus x. So this implies that x lambda x over x factorial into bracket 1 into bracket small bracket 1 minus 1 over n bracket into bracket 1 minus 2 over n all the way to 1 minus x plus 1 all over x bracket 1 minus lambda n x. So let us introduce limits. So it will be lim as n is approaching infinity of lambda x over x factorial bracket 1 minus 1 over n 1 minus 2 over n all the way to 1 minus x plus 1 over n 1 minus lambda n all over now 1 minus lambda n x. So by laws of indices, use laws of indices there, we use the laws of indices here. So it will be lambda x factorial into bracket, as n here is approaching infinity, this value here will be approaching 0. 1 minus 0 is equal to 1 times, as n is approaching infinity here, 2 all over n is approaching 0. 1 minus 0 will be 1 times, as n is approaching infinity here, x plus 1 divided by that n which is approaching infinity will approach 0. So it will be 1 minus 0 will be 1 times, this one will be exponential of negative lambda all over 1 here. So multiply this one, it will be lambda x all over x factorial times exponential of negative lambda, and multiply this will be lambda x exponential of negative lambda all over x factorial. So we've shown here that this formula here is approaching this one. This one is binomial, this one is Poisson. So therefore binomial distribution is derived from this Poisson distribution here is derived from binomial distribution as shown down here. So thanks for watching. Subscribe, comment for more videos. Thanks.